When you create object-oriented programming applications, you have to apply its principles. Object-oriented programming comes with 4 key principles that you should be aware of, so you will understand how you should design your large programs so it will be easier to keep developing it. And I'm going to talk about those principles, which are encapsulation, abstraction, inheritance, and polymorphism. Now, those principles are also asked in a lot of interviews. I can personally tell for myself that in the latest job that I'm working currently right now, I have been asked about the principles of object-oriented programming, so I believe that in addition to improve your object-oriented programming skills, this video will be also very helpful for trying to find your first job as a software/DevOps engineer. By the way, that will be the final episode of this entire course, so I hope that you enjoyed throughout this series. If you will enjoy the content of this episode as well, be sure to hit the like button and as well as subscribe to my channel. Let's get started. So the first principle will be encapsulation, and we will talk about this a little bit. So encapsulation refers to a mechanism of restricting the direct access to some of our attributes in a program. Now notice how we did a great job in the last part where we implemented the encapsulation principle on our project. So pay attention to how the name attribute could not be set to a new value before it goes through some conditions that we set here, like the length of the character being less than 10 characters. So restricting the ability to override the values for your objects within your setters is exactly what the encapsulation principle is about. Now, to even give you a better example of encapsulation principle, then we are going to apply similar things to an additional attribute, which is going to be the price attribute. Now, if we take a quick look in that program that I have just executed, then you can already see that I have the ability to directly set this object into whatever number that I like to. Also, -900 will work here. So that's probably something that we look to change. And the way that we can change that is by implementing some methods that will restrict the access to this price attribute. So it could have been nice if we could have 2 methods that will be responsible to increment this price by some percentage amount, and the same goes for the discount. Now, if you remember, we already came up with a similar method that looks like apply discount when we talked about class attributes, because self.payRate multiplied by the actual price is actually going to change this attribute being decreased by 20% because pay rate is set to 0.8 if you remember from the previous episodes. So let's go ahead and continue designing this price attribute to totally support the encapsulation principle. So first things first, I'm going to convert this price into being a private attribute, so it will be a great start avoiding to set this price directly like we have seen previously. Now I'm not going to just add here double underscore, besides I'm going to grab this whole thing and I'm going to right click and then I'm going to say refactor rename, and then I'm just going to rename this price by setting it like that, double underscore before that. Now doing this is actually going to refactor this change on the entire class where we try to access the price attribute. So that is a great thing, so we don't really have to change everywhere. So once I have done that, then if we would also take a look in the apply discount, then you can see that we have this being set to a new variable name that we came up with. So now that we have done this, then let's go ahead and create a property so we will have the ability to access the price attribute temporarily being only read-only. So I'm going to say add property, and then I'm going to say def price. Then I'm just going to return self.price. So that's a great starter to restrict the access to the price attribute, because now we still have access to the price attribute and then we cannot set that. So you can see that if we were to try to access item1.price, we will have some errors, but we can just access the actual value of that where it comes from the initialization. So that's a Oh, actually, I see that we hit an error that says recursion error, and that's probably because I did not add the double underscore in here by mistake. So that's actually a great exception that we came across right now. You can see that we are going to hit recursion error, maximum recursion depth exceeded. And that happened because I tried to return the price without the double underscore. So if we try to call the self.price, then it is going to try to call this function. And if we try to return that, then it's just going to loop over it again, and in some time it's going to fail with the recursion error, as you see. So that's actually a great exception that we see now, and if you see this exception in your object-oriented programs, now you know how to handle it. And if I was to come back now to main and execute that, then you can see that the expected result is here. Alright, so now that we have done this, then let's go back to our class and try to work on our methods that will modify the attribute of double underscore price. So I will actually cut this method from here, and I will just put that right under the property price that we came up with, so we will have a cleaner look. Now, first things first, you can see that we have the apply discount, and we will also like to come up with apply increment like the following. And we would like to say here self dot double underscore price is equal to self dot double underscore price plus self dot double underscore price multiplied by some value that we can receive as a parameter. So we could actually receive a parameter that we could name increment value, and then we could just multiply it by that number. So now that we came up with this, then let's test this up. Okay, I'm going to go back to my main.py, and then I'm going to call item1.apply increment, and then I'm just going to pass in 0.2. So we will increment the value of 750 by 20%. Now the next time that I access the item1.price, we should be able to see the actual value of price, which should be 900. And if I was to run that, then you can see that the price has been incremented to 900 as expected. So that is exactly encapsulation in action, because you go ahead and you don't allow the access directly to the price attribute. Besides, you modify this attribute by using methods like apply increment or apply discount. Now the same will happen if I was to now go ahead and use item1.apply discount. And you can actually modify this method in the way that you'd like to, but this currently refers to a class attribute that we use here. So this should also, again, apply a discount of 20% to the 900 price. We should be able to see 720, and that's exactly what is happening here. Alright, so the next principle that I'm going to talk about is called abstraction. Now, abstraction is the concept of object-oriented programming that only shows the necessary attributes and hides the unnecessary information. Now, the main purpose of abstraction is basically hiding unnecessary details from the users. Now, by saying users, I basically mean people like me or you that are going to use the item class to create some item objects. Now we can see that now we have a new program here that has one item object, that its name is my item, price being that number, and we have 6 from this item. Now we can also see that I came up with a method that doesn't really exist, which is called send email. So that method at the end of the day should send an email to someone that would like to decide about this item, and it will send info about how much money we can earn by selling all the items, and maybe about some more info that is related to this item. Now, sending an email is not as easy action just by calling it with that way, because in the background, email sending has to go a lot of processes like connecting to an SMTP server, and as well as preparing the body of the email with an auto message that will display some info about this item. So as we can understand, we have to go through a lot of new methods before we go ahead and just call a send email method. So to simulate that, then I can actually go ahead and say send email. So I will just create the method that is necessary, temporarily I will use pass. Now, as I said, we also have to go through a lot of other processes, so it is a great idea to create methods for each of those processes, like connecting to an SMTP server like that, and I will just say pass because we only try to simulate the idea of abstraction here. I'm not really going to send an actual email to someone, I'm just simulating an idea of sending an email. And we will also have to go through preparing a body for an automatic mail, prepare body, right? And then I can just return a formatted string that will say something like hello someone. We could receive this as a parameter as well. And then we can say we have self.name 6 times, right? So it should be 6 self.quantity times like that. Then I can say regards gym shaped code. So that is just a very simple email that we can send to someone. Now you can understand that we have to call those methods inside the send email. So simulating that will be self.connect and then self.prepare body. And probably we also need to go through sending it, right? So I can just say something like send here, then use pass again. Now you can see that those methods at the end of the day are only going to be called from the send email because those are just parts of the email sending process that is a bigger process that we divided into multiple steps in this class. Now the biggest problem is we will have access calling those methods from the instance, and that is exactly what abstraction is about. Abstraction principle says to you that you should hide unnecessary information from the instances. So that is why by converting those methods into being private methods, then we actually apply abstraction principles, and that is achievable in Python in a way which, I'm going to be honest, is not too much convenient, but it is achievable by adding double underscore. Now again, in other programming languages this is achievable by having access modifiers for your methods like private or public, and I'm talking about programming languages like Java, C#, etc. So if we were to convert those methods to private methods by only adding double underscore, then those only could be called from the class level, meaning inside the class. So if we were to try to access it, then you can see that I'm going to have autocompletion, meaning I will have the ability to access those methods. And then I will just do the same for the other methods. Now this error comes from here because we did not really specify some argument. I'm just going to add an empty string. Now if I was to go back to our main.py file, then you're gonna see that we are going to have some troubles. Even if I'm going to try to access it with a double underscore, I'm not even going to have an autocompletion. And the reason for that, it is because that is a private method. So you really have to think about your methods if you want to make them accessible outside of your class, meaning from the instances. And that is exactly what abstraction is about. You want to abstract the information that is unnecessary to call it or to access it from your instances. Okay, so inheritance is the third principle of object-oriented programming. Inheritance is a mechanism that allows us to reuse code across our classes. Now that's something that we have totally designed well throughout this course, because we came up with more classes that are child classes of the item class, where each child class represents a kind of an item. Now pay attention how I changed the import line from phone import phone, and I used the child class of item which we came up with, which is called phone. You can see that I'm passing similar arguments, and I can still use a code that is implemented in the parent class. If we were to execute this program, then we are not going to receive any problems, because phone uses all the methods and attributes that it inherits from the item class, which is exactly here. And if we remember, we designed the send email method in the parent class, and we can use it from the instance of a phone. And we can also do that for the rest of the methods that we came up with that really affect some of the attributes, like in the encapsulation part where we applied the apply increment method that receives an increment value. And if we were to test this, incrementing the price by 0.2 and then printing item 1 dot price, then we should see 1200. So if we were to print that, then you can see that that is exactly the result. So that is mainly what inheritance is about. It is about reusing the code across all the classes, and that's exactly the scenario here. And the beauty behind that is that you can come up with more child classes that will represent kinds of items like laptop, keyboard, camera, everything that you think about, and then you can just modify specific methods that you'd like to according to the kind of item that you have. So that's perfectly describing what inheritance is about. Alright, so the last principle that we have now is polymorphism. Now, polymorphism is a very important concept in programming. It refers to use of a single type entity to represent different types in different scenarios. Now, a perfect example for this definition would be some of the functions that we already know that exist in Python. Now, just a quick side note, polymorphism refers to many forms, poly being many and morphism being forms. So again, the idea of applying polymorphism on our programs is the ability to have different scenarios when we call the exact same entity, and an entity could be a function that we just call. Now, as you can understand, polymorphism isn't something that is specifically applied to how you create your classes. That is actually something that refers globally to your entire project. And in the next few minutes, we are going to see some bad practices where polymorphism is not applied, and we are also going to see where in Python polymorphism is perfectly applied. So a great example of where polymorphism is applied is in the len built-in function, because the len built-in function in Python knows how to handle different kinds of objects that it receives as an argument, and it returns you a result accordingly. So as you can see in here, if we were to use the len built-in function in a string, then we will receive the total amount of characters. But if we will do this in a list, then we will not receive the length of characters of this entire expression in here. Besides, we will receive back the amount of elements that are inside this list. And to show you how this is going to work, then I'm just going to run this program, and for sure the results are just as expected. So as the definition of polymorphism says, it is just a single entity that does know how to handle different kinds of objects as expected. Alright, so now that we understood that the polymorphism is applied everywhere in Python, especially in the len built-in function, let's also understand where it is implemented on our project here. Now you can see that I try to call the apply discount method that is never implemented inside the phone class, and the fact that I can use it from the item class, it is because we inherit from this class, and that is the basically reason. Now, if I was to go back to that main.py file and run this, then you can see that that is going to work because the apply discount is a method that I can use from the inherited item class. Now, that's exactly where polymorphism is also in action, because polymorphism again refers to one single entity that you can use from multiple objects. Now, if I was one day to go ahead and create more kinds of items, meaning more classes that will represent different kinds of items, and from them to call the apply discount method, that's also going to work, because the apply discount is a method that is going to be accessible from all the kinds of objects. So that's exactly why you might have heard about the terms of inheritance and polymorphism together combined. Now, to show you that, then let's try to create one more class that is going to be identical to the phone class, right? I'm going to create a keyboard file, and then I'm just going to say here class. You know what, before that, let's go to phone and copy everything from here and paste this in like that. I'm going to get rid from those lines, and I'm just going to leave the init as it is. I'm going to change the class name from phone to keyboard, and I'm also going to delete that attribute that we don't need, broken phones. Alright, so now that we have this, then I can actually go ahead to my main.py file and use one more import line that will say from keyboard import keyboard. And then I'm going to change this to keyboard. We'll replace this name just to make it more realistic. Then I'm going to run the same program. You can see that this works. So that's again exactly where polymorphism is in action, because we can use this single entity from different kinds of objects and it will know how to handle it properly. Now by saying handle it properly, then I basically mean you can have the control of how many amount of discount you want to apply inside your classes now. Because if we were to go to keyboard and use a class attribute exactly like we used in the item class, which was pay rate, then we're gonna have full control for all the discounts that are going to apply to the keyboard. And to show you that, I'm going to attempt typing in pay rate, and you can see that I even have auto-completion because overriding in the child class, that is legal. Alright, so I can just say pay rate is equal to 0.7 and that will be it. Now I have the same discount amount for all my keyboards. If I was again to run the main.py file, then you can see that the results are just as expected. We see 700. So that is the beauty behind inheritance and polymorphism together. And the same will go for sure if we were to decide that we'd like to have 50% discount. So it will only take from me to go ahead and say pay rate is equal to 0.5 and that's it. So I hope that you understand about polymorphism a bit better now. Now, just a quick side note, polymorphism is perfectly could be implemented by using abstract classes. And that is just the identical way of using interfaces in other programming languages like Java. Interface is a way that you can implement how a class should be designed, alright? So it is like a template for a class. And that is achievable by using abstract classes, which I'm not going to cover in that part. But again, polymorphism, like I said, is a term that is implemented in different areas in the whole Python programming language. So I hope you had a great time learning the object-oriented programming course. Now you have a lot of tools that you can go ahead and try to implement by yourself on your projects, which will really help you to take you to the next step as a developer. So if you enjoyed this entire series, please be sure to hit the like button and as well as subscribe to my channel so you will never miss any tutorial that I upload. See you next time.